G'day, Lance from Motive Power back again. We're continuing the saga on how to professionally design off-highway vehicles. Today, we're talking about skeletons, or chassis for vehicles. So what's the chassis? It's the structure, the skeleton, that holds all the components together and turns the vehicle into a single entity rather than a disparate collection of parts. But it's not quite that easy because there's a whole range of different chassis approaches that can be taken. Some are easily selected based on the application, some are a little more difficult. So we're going to have a look at a few. The first one is a space frame. You've probably heard the term, but may not know what it is. It's a frame that's made up of multiple smaller tubes, and the concept is that all of those tubes are in either tension or compression, that none of them are in bending. Why not? If I wanted to break this pen, I could pull on it, I could push on it, I could twist it, didn't break it. But the one way I can break it easily is to bend it. Bending is usually the easiest mode of failure. So taking that capability out of a chassis can be important. It also tends to make the chassis lighter by using multiple small components. Let's have a look at some examples. You might not recognize it without its clothes on, but this is a Mercedes-Benz 300 SL, the famous gull-wing Merc. You'll see a multitude of tubes tying everything together with lots of diagonals to hold it all rigid. This photo is a good one because it actually shows why you can never have a true space frame. Although there's a very credible attempt made here, you can't always run members where you want to because there's other things, more important things, in the way. For example, passengers. You'll see this is an open area. No diagonals run through it. Fuel tank's another area. Diagonals over it and probably under it, but not through it. So that's a 50-0 vehicle, a very high performance vehicle. And if I remember correctly, the first to do more than 100 horsepower per litre without a turbocharger. I've also had the honour of working on an overhaul of this and driving it. One of the notable features is this box structure along the side. It makes it much harder to get into the vehicle. You actually have to step way in to get over this box frame here. But it's not the only vehicle at space frame. This is the chassis of what was known as a birdcage Maserati. Look at all the tubes, hence the name birdcage. But again, a very famous classic car. Just imagine how you do a crash repair on that. It's done because it's very light and it's very rigid, but there's a lot of work involved. This sort of approach, perhaps not to the same extent, is often used in race cars and off-road racing in particular. And these days typically uses chrome moly tube. Chrome moly is about twice the strength of normal tube. But what most people don't realise is the heat affected zone around the world has about half the strength of the native material. So the body of the tubes are going to be twice as strong as normal steel, but the world's aren't. Moving along, here's a ladder frame. And it's pretty easy to see why it's called a ladder frame. Two longitudinal members with some cross members. There's a little bit of effort here to make it into 3D, but that's probably dips down there more to let the passengers get in and out easily. This is very common on a traditional car, what would be called body on frame these days. Some of these members, normally they'd be a little thicker, they might be a bigger tube to try and control a bit of torsional deflection. But most trucks, for example, are ladder frame chassis. So this tends to be easier to make it strong, not so good in twisting. And for that, you might want to try a different approach. So let's look at a haul truck chassis. Specifically, this picture here. It's a ladder frame, two longitudinal members. With cross members, you'll see that's quite large, and that will help a lot to limit torsional deflection. But it has what we used to call a horse collar. Now, the engine goes in here. That's why it's a horse collar, to let the engine stick through. But that gives you a lot of torsional rigidity in this area, particularly when the suspension is mounted directly on it. So ladder frame chassis still in use in many applications. You just have to make sure they're up to the duty. This is a Bliss Fox F1450 aircraft towing tractor. So it's 54 tonne of machine, and the chassis is essentially a base plate with verticals, all of 80mm plate, mild steel. There's about 35 tonne of what you'd consider ballast in this vehicle, but instead of having separable ballast, it was built in as steel. That may surprise most people, but using raw steel is still cheaper than concrete and lead. So don't be afraid to make a big, heavy, strong chassis if the application will sustain it. I've used the Ventrac as an example a few times now. This is a really good design. In terms of the chassis, it's maybe not completely obvious here, but nearly all of that chassis, almost everything you can see there, is essentially sheet metal. Folded very creatively. They do the same with their buckets and grapples and so forth. There's some really good sheet metal design in there. By being able to fold it in different locations, different ways on the one piece, minimised welding, but they can still attach to a wide range of components. Now, there's a lot of discussion these days about four-wheel drives, whether they should be body on frame or stress skin, which the car companies tend to call unibody. This is an example of a unibody. No specific chassis. The strength is in this case, in the hull. This is an amphibious vehicle, an Argo. So this whole design actually allows it to be waterproof and to float. Sometimes this is called monocoque because the stress skin approach started in Formula One cars, where it was in fact monocoque, one seat, one cockpit. But that term's sort of fallen out of favour now. So a lot of cars are in fact stress skin, monocoque, or unibody, or whatever term you prefer. Then who doesn't like an old tractor, particularly when it's polished up like this one? Where's the chassis? Well, it is actually the engine and the transmission. That's the thing carrying the load and tying the whole vehicle together, even the steering axle. If you think this is an old idea, you're right, but it's still done today in agricultural equipment, and at least Cummins have an engine that has a block suitable for this sort of application. So it's an old idea, but still relevant today. And this might be one you haven't seen. This is from Tatra, a truck company in the Czech Republic. The chassis is one big tube. As they say, a rigid central backbone tube. Runs the full length of the vehicle with mounts coming off it for the body. The drive shafts are all encased within that tube, as are the differentials, and the suspension is attached as appropriate. This is swing arm suspension. These vehicles are very rigid, very robust, and carry big loads. There are some applications where the swing arm suspension is suboptimal, but on the whole, this is a great concept where you can take a chassis, essentially body on frame, but the difference here is you can pressurize that entire tube, all of your drivetrain components, and keep the dirt and the water out. I used the Ventrac earlier as an example. What I should have also pointed out is that this is an articulated vehicle. There's a pivot pin in the middle, pivot joint. So in fact, it has two chassis, not just the one. It has a front and a rear. So the design of the vehicle has progressed through engines and transmissions, axles, ground interface, and we now know how we can tie it all together. There's a variety of chassis, and you can use them in combination. They don't have to be exclusively that. There are, of course, new developments. You drive a Tesla, you'll know that there's a very big injection molded casting. That's used for the rear part of the vehicle. But generally, from fairly early on, you'll know what sort of chassis you're going to have. If it's a truck, it's probably ladder frame, just because it's easier to attach everything to it. If it's a military vehicle, it's probably some form of monocoque, because you're going to make a hull and attach things to that. The application, once again, drives the design. Not exclusively, but quite often. But to define the chassis, you need to know where all the big lumps are going. The engine, the transmission, the axles, and so forth. Put those on a model, look at it, and it'll almost definitely tell you what sort of chassis you're going to have. So consider all the options, work out the best one for you, even if it's a blending of a couple of different alternatives, and then move confidently on to design the rest of the vehicle.